Hello, this is Gregory Maxwell, and in this lesson, we will be talking about factoring polynomials. Factoring polynomials. Some of the slides in this PowerPoint presentation will be taken from Shauna Hader's PowerPoint presentations on polynomials and factoring polynomials. So let's get started. First of all, let's do a quick review of polynomials. Polynomials are special expressions that combine variables and coefficients. But let's just look at a few terms here. The prefix mono means one, and the prefix bi means two, and the prefix tri means three, and poly means many. So a monomial is a one-term expression, a binomial is a two-term expression, and a trinomial has three terms. And the terms are separated by the operations of either subtraction or addition. So a polynomial is a many-term expression, and because the prefix poly means many. Now, actually, in general, these type of expressions are all classified as polynomials, whether they have one term or many terms, one term or more terms. So bear that in mind when we talk about polynomials. Now let's talk. We mean multiple terms. Now let's talk about what a polynomial looks like. A polynomial expression has a variable. Here it's represented by x, and actually we're talking about a polynomial in one variable. There are other types, but we're keeping it for simple here for basic mathematics, for basic algebra. And then so the variables have numbers in front of them. Those numbers are called coefficients. It tells you how many instances of a term there is. So x to the n is there this number of times, and that a subscript n represents a real number in this case. The highest power of the variable is called the degree of that term. The power of the variable is called the degree of that term, and the highest degree is the degree of the polynomial. So we have, in this case, the degree would be n, and the leading term would be the expression, the term with the x to the n. The coefficient of that term is called the leading coefficient. So when you're adding polynomials, you can add them by adding corresponding terms known as like terms. That means they have the same variable with the same degree. And in this case, we have a four-term polynomial. The degree is 3. The leading coefficient is a 3 as well, because that's the number in front of the term with the highest degree. And we're adding a third degree polynomial to another third degree polynomial. What we would do is add the x cubed terms together. So that's 3x cubed plus 2x cubed. Then we'll add the negative 2x squared plus the x squared, that's the x squared terms together. And then we would add the x terms together, 4x plus negative 2x. And then we'd add the constants together. In those cases, constants are considered to be degree 0 terms. And so we end up with this result after the addition of the polynomials. Subtraction is similar, but remember now, when you're subtracting the whole polynomial. So you can just multiply each term by the negative, or actually negative 1. The number that's missing here is 1. So we're distributing the negative, and then we combine like terms again. 3x cubed plus negative 2x cubed is 1x cubed. Negative 2x squared plus negative x squared is negative 3x squared. 4x plus 2x is 6x. And 3 minus 1, or 3 plus negative 1 is positive 2. Notice that all the signs got switched around here. Now, when multiplying polynomials, what we're going to do is multiply each term in one polynomial by each term in the other polynomial. That's generally called distributive property. So I'm going to multiply the 3x by each of these terms in the second parentheses. Then I'll multiply the negative 2 by each of these terms in the second parentheses. When you're multiplying a binomial by a binomial, that process is often shortened and represented by the mnemonic FOIL, the mnemonic FOIL, which means first, outer, inner, last. And what I mean is multiply the first terms by the first term, then you multiply the outer term by the outer terms, then you multiply the inner terms, and then you multiply the last terms. So that's what FOIL means, and then you combine like terms. In this case, you can combine the 3x squared, the 12x plus the negative 2x to give you positive 10x. But generally speaking, it's really just distributing, using the distributive property, multiplying each term in the first parenthesis, first pair of parentheses by each term in the other pair. So for example, in this case, we're going to multiply the 2x by each term in the second parentheses, which is 2x times 3x squared, 2x times negative 2x, 2x times 4. And then we're going to do that same thing with the negative 3. Negative 3 times 3x squared, negative 3 times negative 2x, and negative 3 times 4. We combine those together. We do all of that process, and then we put the like terms together. And in this case, I'm going to put the negative 9x squared with the negative 4x squared, and the positive 6x plus the 8x, but the negative 12 and the 6x cubed have no common term, so just leave them. So we just write them like that and combine like terms. And that brings us now to the steps about factoring polynomial. So we've just reviewed what polynomials are and some basic operations. Now we're going to talk about factoring polynomials. In this process, we will be looking at factoring using finding the greatest common factor of the terms. We're going to talk about a couple of special types of binomials called difference of squares and sum or difference of cubes. We're going to talk about factoring by grouping, factoring trinomials, factoring special trinomials that form a perfect square, and then we're going to talk about solving some equations, polynomial equations by factoring. And then we'll wrap up with some word problems. So here's our first step. We're going to talk about the first rule of factoring. And the first rule of factoring is to see if there's a common factor and factor the greatest common factor out. If you look at this term, this expression here, both terms, we have a 15 and a minus 5x. Both terms have a 5 in common. Now in this PowerPoint here, we are going to factor out a negative 5, but generally speaking, we want to factor out, if there's a negative first term, we'll factor out the negative as well. But if there's not a negative first term, we typically don't. In this case, we're factoring out negative 5. And then what that means is we're doing the reverse of the distributive property. We want to find out what do we multiply by negative 5 to get 15, and what do we multiply by negative 5 to get negative 5x. Negative 5 times negative 3 is 15. Negative 5 times x is negative 5x. So that's what we leave in the parentheses. Another way of thinking about it is we divide each term by the common factor. So since the common factor is negative 5, I divide 15 by negative 5, I get negative 3. I divide negative 5x by negative 5, I get positive x, because a negative divided by a negative is a positive. If you do the distributive property, you will get the original expression back. So we are on the right track here. So let's do a few examples of factoring by greatest common factor. Let's factor using the greatest common factor here. And these exercises are from the book Intermediate Algebra, 2nd edition by Miller, O'Neill, and Hyde, section exercise 5.4. So let's start off here by looking at these questions. Pretty simple. The first rule of factoring is to seek for the greatest common factor. What is the greatest common factor of 15x minus 10? The greatest common factor of the numbers is 5. And actually there's only one variable in one term, so there's no common variable, so the only common factor is 5. And we're dealing with common factors of whole numbers or at most rational expressions, otherwise it gets a little tedious. So now I divide 15x by 5, that leaves me with 3x, and I divide negative 10 by 5, that gives me negative 2. So that's the end of my expression. This is now factored. And as a side note here, to factor means to express as a product of its factor. And to factor completely means to factor in such a way that the factors cannot be broken down into anything smaller. Now in here, we see that the common factor for between 49 and 35 is 7. 7 is a number that can go into both of those. Then I look at the variable. There's 3y's here because it's y cubed, 3y's multiplied together, and 2y's multiplied together. That means each term has a y squared inside that can be taken out. And that's the most y's I can take out of each term. So I now divide. 49 divided by 7 is 7, and y cubed divided by y squared is y. Negative 35 divided by 7 is negative 5. Y squared divided by y squared is 1. And I don't need to write it because that would be just multiplied by the 5. And that's all we have. And there we have it. Pretty simple. In this case, the common factor of the numbers is 4. We have an a square here and an a square here, so a square is common to both terms. We have a b cubed here and a b here, so b is common once. And now we go through. 8 divided by 4 is 2. A squared divided by a squared is 1, so we don't need to write that. And b cubed divided by b is b squared. So we have that first term. Plus 12 divided by 4 is 3. A squared b divided by a squared divided by a squared is 1, and b divided by b is 1. Each of those would multiply by 3 to just leave the 3. So we don't need to go any further. We leave the answer as that, and that's factored completely, at least at this point. Well, yes, completely. Now let's take a look at this trinomial here. The degree is 3 and the leading coefficient is 6. The common factor here, the numbers have no common factors because the only common number between 6, 2, and 5 is 1. And so we say these are relatively prime, but that's a separate concept altogether. Now let's look at the a's. Do we have a's in each term? Yes. How many times is a common? Twice, because you have 3 a's here, 2 a's here, and 2 a's here. So a squared is a common factor. B is not in every term, so there's no other common variable. Then I divide. 6a cubed divided by a squared leaves only 6a. And you can think of it as what do I multiply by a squared to get 6a cubed? Then I do 2a squared b divided by a squared. So it's negative 2b because the a squared would have cancelled. And then positive 5a squared divided by a squared is just 5. And that brings us to the end of that example. Let's move up to a few other examples here. Now in this case, we're going to go through the same process, but as you can see, they look a little bit more tedious. But it's the same idea. The difference there, though, is the things that are common are actually in parentheses. If you look at both sets of parentheses in number 33, for example, both sets of parentheses have the same expression. And so when we look at the coefficients, there's no common number. 2 and 5 only have 1 in common, and a is only in the first term here. But if you look, they both have 3z minus 2b as parts of the terms. So what we're going to do is factor out that expression. We're going to treat that expression as a variable, like one variable, like a p. And I'm just going to factor that out, 3z minus 2b. And then what I will do is go to each expression and see what would be left over if I were to cancel out that 3z minus 2b or divide it out. What would be left is 2a in the first case, and then in the other case we'd have minus 5, a negative 5. And so that would be the end of our factoring experience right here. The common factor was only just this, items in the parentheses. Once again, in this case, we have a common factor, the same expression, that's what's common to both terms. So that's what we're going to factor out. And as before, there's no common number and there's no additional variable outside. So when I factor that out, I just have 2x minus 3. And then 2x minus 3 we factor that, we end up with 2x squared, and then 2x minus 3 times what gives you 2x minus 3? 2x minus 3 times 1. So I'm saying this divided by itself is 1, and there we have it, completely factored. Now we go to this one here, number 37. Y is outside of the first parentheses and 3 is outside the second. That's not common. However, we can see again that the parentheses are common, 2x plus 1. But both of them are squared, so 2x plus 1 in parentheses squared is common to both terms. And then we go through and say if I divide by 2x plus 1 squared, what's left? Y. And 2x plus 1 squared here factored out leaves negative 3. And there we have it. Very easy process, factored by finding the GCF, the greatest common factor. Now in this case, we look for the GCF again. We see that 3 is a common number between 3y and 6. So 3 is common, but the y is not common. So we can't, that's not common anymore. But also, x minus 2 is common in both terms. So both terms have an x minus 2 squared. So the GCF is actually all of this thing here. That's the GCF. And then what is left over? What is left over is, after I take out 3 here, I just have a y left over here. And the x minus 2 squared is all gone, leaving just the y. Over here, 6 divided by 3 is 2. And the x minus 2 squared is common already. That's all gone. So that leaves only the y plus 2. And again, remember, always check for the GCF first. Check for the GCF first. All right? That means including for the coefficients. Now let's take a look at this one. This common GCF here is 2. And if we go to the parentheses, we have z. And because I don't want my z's to look like a 2, I'm going to put a slash through my z. So z plus 3. And then both terms have a z plus 3 squared. And that's my GCF. And then 2 into 10z is 5z. And then z plus 3 squared is cancelled. Negative 2 divided by 2 is negative 1. And z plus 3 squared is cancelled. And that is our result. So there we have a number of examples about factoring by looking for the greatest common factor. Now let's talk about factoring a binomial. Now there are two binomials that we're going to talk about factoring. We're going to talk about factoring a difference of squares, which means a squared term minus another squared term. That's called a difference of squares. Now, if you recall from multiplying polynomials, which we didn't do much in this video, but you might notice that if you multiply what we call conjugates, we end up with a difference of squares. So that means if we're finding the difference of a difference of squares and we factor it, then we end up with the product of conjugate pairs. So the difference of squares factors into conjugate pairs. What are conjugate pairs? These are pairs that have the same terms, but the sign separating the terms are different. The operations, separating the terms are different. One is positive, one is negative. So the conjugates here would be 3z plus 5 and 3z minus 5. Those are conjugate pairs. Now when you factor conjugate pairs, when you distribute conjugate pairs, you get a difference of squares. So that brings us to a simple rule of factoring, which is always if you have a difference of squares, you just have they factor to be conjugate pairs of the square roots. The square root of 9z squared is 3z. The square root of 25 is 5. So the factoring of 9z squared minus 25 is 3z plus 5 and 3z minus 5. And again, remember, when we're doing factoring, always check for greatest common factor first. Always check for a common factor first. So let's check this out. Is there a common factor here? Yes. A is common to both terms. So I'm going to factor out A first. Once I factor out A, what's left behind is A squared minus 16. That's a binomial, and it looks like a difference of squares. A squared is the square of A, and 16 is the square of 4. So then I can factor A squared minus 16 as A plus 4 times A minus 4, which is a product of conjugates. And we have the original factored A out in front. So let's do a few more examples here. And this time, we're going to use this rule here. A squared minus B squared is A plus B times A minus B, which is a difference of squares is the product of conjugate pairs of the square roots. So in this case, we see here that y squared minus 25 is actually, I'm going to just write this in green to indicate that's an intermediate step. That's just a difference of squares, y squared minus 5 squared. So that's my difference of squares. So then I factor that out. The result is the product of the conjugate pairs of the square roots. Y squared is the square of y, and 5 squared is the square of 5, and one parenthesis as plus and the other as minus. It doesn't matter if you put the minus then the plus or the plus then the minus, but one, they should be mismatched. They should be conjugates, and that's the answer. Let's try this one here. Same deal. What do you square to get 81? 9. What do you square to get b squared? B. And so the conjugate pairs here are 9 and b. 9 plus b and 9 minus b. And as I said, you could put the minus, then the plus. Then number 17. As always, we always check for the greatest common factor. And when we check here, we realize that 8 is actually a common factor. Well, not 8. 2 is a common factor between 8 and 162. If I factor out 2, I get 4a squared minus, and 2 into 162 is 81. So I factor out the 2 first. Always do the greatest common factor first. Now, I notice here that the stuff in parentheses is a difference of squares. It's actually the square of 2a minus the square of 9b. So there we have another difference of squares. So we can factor that by the product of the conjugate pairs. 2 is the original common factor. Then my first conjugate pair is 2a plus 9b. And my second conjugate pair is 2a minus 9b. And that's the end of that exercise. Let's go on to this one. Same deal. Look for a greatest common factor. Seems like 2 is another common factor here, and there's no other common factor. 50c squared divided by 2 is 25c squared, and 72d divided by 2 is 36d squared. And again, remember now, if we can identify a difference of squares, we do. 25c squared is actually the square of 5c, and the 36d squared is the square of 6d. And then we do the difference of squares. 5c minus 6d times 5c plus 6d. And of course, we have the 2 that was factored out front. Now, let's move on to the next example. In this example, we have 25u squared plus 1, and we check for common factor. There is none. The problem is this is a plus, not a minus. And in reality, this expression cannot be broken down into simpler factors without possibly using what we call complex numbers, which is for a later thing. So it doesn't factor into real number, real coefficient expressions, so we leave it like that. The same thing happens with number 20. So we say that those are prime. These do not factor into anything simpler, because this is not a difference of squares. Sums of squares do not factor into real coefficients. So we say they're prime, which means they cannot be broken down into simpler expressions. Now number 21, greatest common factor here is 2, and then we have a to the 4 minus 16. And now I realize that this is actually a difference of squares if I think of it as 2 times a squared minus 4 squared. So we have a difference of squares here. So when we factor that out, we end up with 2 times a squared minus 4, and then times a squared plus 4. And that is the product of the conjugates. But before we move on, we realize that this expression here also looks like another difference of squares. So we have another difference of squares again. It's the difference of squares. However, this one is just prime, because that's a sum of squares. So that one does not factor. That's prime. So what we're going to do is do the difference of squares and then leave the other parentheses as is. So that would be a plus 2 times a minus 2. And then the prime factor will remain right there, a squared plus 4. We'll leave it like that. Similarly, for number 22, common factor is 5. We have y to the 4 minus 1, and that actually is y. 5 is y to the 4 is y squared, and 1 is 1 squared. 1 can be raised to any power, you'll still get 1. So we factor that. We do the conjugate pairs, y squared minus 1 times y squared plus 1. And again, this is another difference of squares, so we can factor that out as 5 times y minus 1 times y plus 1. That's the factoring of this first pair of parentheses, and the other pair will just stay the same. That's the end of that example. Now, there's another rule for adding and subtracting cubes. So we have a sum of cubes and a difference of cubes. And that one factors in a more complicated way. So when you do a sum or difference of cubes, first we have to identify which one we have. We have a sum of cubes, which is a cube of an expression by times plus another cube of an expression, or a cube minus a cube. In this case, 3s cube, the cube of 3s is 27s cubed, and the cube of 4 is 64, and they're added, so we have a sum of cubes. And the expression is, now this becomes a little tricky. 3s plus 4 is the first terms. 3s times what gives 27s squared? That is 9s squared. 4 times what gives 64? 16. And then the middle terms would combine to give negative 12s. Now, it's easier to just memorize the rule. And the rule, as we'll show in a minute, is, and as you saw in the previous slide, a cubed plus b cubed is a plus b times a squared minus ab plus b squared. And if it's a minus, then we have a reverse. First term is a cube, second term is a cube, and we're adding, so we just go through the same process. 4v plus negative 5, and then the negative 5 squared would be 125 here, and then the 4v squared would be 16v, and then when you multiply the two middle terms, you get 20v. But the signs switch around. So that's the formula. Now, to make it easier, it's just easier to just memorize what we have here at the top. A cubed minus b cubed is a minus b times a squared plus ab plus b squared. A cubed plus b cubed is a plus b times a squared minus ab plus b squared. The two factors, the factoring of these two cubes are similar except for two signs. If there's a minus here, there's a minus in the first pair of parentheses and a plus in front of the ab. If there's a plus here in the sum of cubes, then there's a plus in the first pair of parentheses and a minus before the AB, so they mismatch. The square terms are positive. Spend some time memorizing those rules. Now let's spend a little time practicing. So we have 8x cubed minus 1. We see that that's a sum, a difference of cubes. And so we're going to write that as 2x cubed minus 1 cubed. So you can then think of it this way. That means your a in the formula is 2x and the b in the formula is 1, and it's a difference of cubes. So we use this middle expression here, and so we're going to use this formula. So the answer then would be a minus b, see, a cubed minus b cubed is a minus b times the square of a, so a squared plus a times b plus b squared. And then I simplify. 2x minus 1 times 4x squared plus 2x plus 1. And that is the end of that factoring experience. Later on, we'll talk about factoring trinomials, but this one won't be factorable either. That is still prime. In this case, we have a y cubed plus a 64. And again, we see that that's a sum of cubes because clearly y cubed is a cube. But 64 we should recognize is the cube of 4. So in this case, I'm going to treat my a as y and my b as 4. And this is a sum of cubes. So we then proceed as such. So we have that's equal to y plus 4. And then we have y squared plus 4 times y plus 4 squared. That gives you y plus 4. And I made an error here. That's supposed to be a minus. It should be mismatched. If this is a plus, then that's a minus. So it's y plus 4 times y squared minus 4y plus 16. And again, this looks like we can factor again. It will look like it can factor a little later on, but that would be incorrect. For this one, as usual, we check for greatest common factor, and 125 is 5 times 5 times 5, and 27 is 3 cubed. There's actually no greatest common factor there except for 1. So we then see that this thing can be factored pretty nicely as, well, it's a cube of 5c plus the cube of 3. So my a here is 5c, so a plus b, and my b would be 3. And so the formula is sum of cubes, a plus b times a squared minus a times b plus b squared. So we go by that, we get 5c plus 3 times 5, the square of 5c is 25c squared, and then negative 5c times 3 is negative 15c, and then plus 9. And that is the end of our factoring. Going on down to the next example now. we see that 216 is actually the cube of 6. So I can think of this as 6u cubed minus v cubed. That's a difference of cubes. So that becomes 6u minus v times the square of 6u plus the product of 6u and v plus the square of v. Simplifying that, we end up with 6u minus v times 36u squared plus 6uv plus v squared. And that's our answer. This one is a little bit more straightforward. We can see that that's 1,000 is 10 cubed. So we're talking about x cubed minus 10 cubed. And that gives you x minus 10 times x squared minus plus 10x plus 10 squared, which is 100. And we can just go through like that. So, of course, I would recommend that you try practicing a lot of these on your own and not simply just watch the video, but you can check the answers with the video. We already see that 125 is a cube of 5, so we're dealing with a pretty simple example here. The cube of 5r plus 1 cubed. That gives us 5r plus 1. And be careful when you're writing the exponents that they don't look like they're next to the number. There should be a smaller number to the top right-hand corner. 5r plus 1, and then the square of 5r, which is 25r squared, minus 5r times 1, which is 5r, plus 1 squared, which is 1. And then we can leave it as that. Now, here's a little review of what we've covered so far. First, when you're doing factoring, the first thing you do is check for the greatest common factor. Here's a nice little example. Greatest common factor is 5x squared, and each term factors out from that. Next, we check for special binomial terms. A difference of squares. A squared minus b squared is a minus b times a plus b, which is the product of conjugate pairs. Or a sum of cubes or a difference of cubes. These are binomials. All right, there's no factoring for a sum of squares. Now, sometimes you come up on a combined situation like this. And so we're going to try this one. The first rule of factoring is to look for the GCF. And we're going to see if there's a greatest common factor in number 41, and it appears that there is. A 2 is common. So what we're going to do is we're going to factor out 2 first. And that leaves us with 1,000 y to the 6 plus x cubed. And now we have a difference of cubes, sorry, a sum of cubes. So I can then write this as 2 times 10y squared, that is cubed. If you remember from your exponent rules, 10 cubed, y squared cubed. Y squared cubed is just y to the 2 times 3, which is 6. And then x cubed is already clear. So we have a sum of cubes. This is a sum of cubes. And so now I do just that. Work with the sum of cubes. 2 times 10y squared plus x times the square of 10y squared minus product of 10y squared and x plus square of x. Simplifying, we have 2 times 10y squared plus x times 10 squared is 100. Y squared squared is y to the 4. And I'm just going to write the 10y squared x as 10xy squared, just alphabetical order. and then plus the x squared. And we're done with that one. It's so easy. The more you practice it, the better you get at it. Now for number 42, we do the same process. This time we're going to factor 2z. And again, so as to distinguish, I put a slash through my z. 2 into 16 is 8, and z to the 4 divided by z cubed. 2 into 54 is 27, and the z's cancel, leaving just that. So we have a difference of cubes. We have 2z times the cube of 2z minus 3 cubed. That's a difference of cubes, so we have 2z is a common factor, then 2z minus 3, then times the square of 2z plus the product of 2z and 3, which will be 6z, plus the square of 3. So that gives us 2z times 2z minus 3 times 4z squared plus 6z plus 9. Going well so far. Let's see what other bounties we have. Now these three look a little bit challenging because we have a little case here where we could use one of two methods. We could either use the difference of squares first or the difference of cubes first. Let's start off with the easier one, difference of squares. So what we're going to do is recognize this as 8x squared. Sorry, 8x cubed squared. We could have written actually a difference of cubes, but the difference of squares is easier, and this is y cubed squared. That is a difference of squares. And again, I could have gone for the difference of cubes because I could have said 4x squared cubed minus y squared cubed. And it would probably be a little bit more work, but just a little bit. And we would end up with the same answers, but probably in different order. Difference of squares. So since the difference of squares, the answer is to write the answer as a product of the conjugate pairs. 8x cubed minus y cubed, and then 8x cubed plus y cubed. And there we have another situation. We have here a difference of cubes. And here we have a sum of cubes, both of which can be factored. So to write them more clearly, I'm going to write this first difference of cubes as the cube of 2x, and of course the cube of y. And then the other one is again the cube of 2x plus the cube of y. So we do the difference of cubes formula, which you can always just rewind the video and check the formula there. First pair is a minus b times a squared plus ab plus b squared. And then that's multiplied by, I'm going to write it a little bit down here because of space, a plus b times again a squared minus ab plus b squared. I'm going to put the binomials next to each other, so we're going to have 2x minus y times 2x plus y. And then we're going to have 4x squared plus 2xy plus y squared times 4x squared minus 2xy plus y squared. And that's our answer. A little tedious, but it worked. Let's follow the same process here. That's 1 cubed minus, well, that's 1 squared minus p cubed squared. That factors out to be a difference of squares, 1 minus p cubed times 1 plus p cubed. And then, of course, that's a difference of cubes and a sum of cubes. So you have 1 minus p times 1 squared plus 1p plus p squared. And then the other one is 1 plus p times 1 squared minus 1p plus p squared. And that's that. I mean, we could end up writing this as 1 minus p times 1 plus p and then multiply by 1 plus p squared, and then 1 minus p plus p squared, and that would be the end of that factoring. Now in this one here, that's not a minus, that's a plus. So that kind of forces our hand, forces us to use a sum of cubes. So let's do a sum of cubes here. Sum of cubes would be, first of all, no common factor, and that would be 3q squared cubed plus 5p squared cubed. That's a sum of cubes. So then we go through the process. A plus b times, and for space I'm going to have to write down here, a squared minus a times b plus b squared. Continue, we get 3q squared plus 5p squared times 9q to the 4 minus 3 times 5 is 15, p squared, q squared, alphabetical order, plus 25p to the 4. And there we have it. Now we're going to move on to our next process, which is factoring by grouping. Factoring by grouping. So how does factoring by grouping work? Factoring by grouping occurs when we have 4 or more terms, usually that we can group together. And usually it works with 4 terms, and it's by grouping by pairing off common, by pairing them off and arranging them so that we can pair them off and factor each pair and see if the part that is in the parentheses are the same, so then we can factor that again. So first we're going to pair these off. 4u to the 4 minus 6u minus 2u cubed plus 3. It's written in a rearranged way so that the cube came after the linear term, so that we can see we can do some grouping here. Sometimes we'll have to end up doing that. So First, we have 4u to the 4 minus 6u. Common factor is 2u. You divide each term by 2u, you get 2u cubed minus 3. Then I'm going to put this negative down here, and I'm going to look for a common factor here, which the only common factor is 1. So I'm going to put a negative 1. I divide by negative 1, I get 2u cubed minus 3. Now, whatever sign is here, it's best to put here. And what we see is that items inside the parentheses are the same, so I can factor those items out. I'm going to factor 2u cubed minus 3, and that leaves 2u minus 1 in the other parentheses, and that's that. This kind of looks like a difference of cubes, but these are not nice cubes, so we'll leave it like that for now. So that's factoring by grouping. So let's do a little grouping. So let's go through the process here. Sometimes we can just group directly. Sometimes we may have to rearrange some expressions to group them. And sometimes it actually doesn't work at all. Grouping is not a process that we could do. In this case, we're going to just try grouping directly first to see if that works. So I'll group the first pair here. I end up with y squared is a common factor for the first pair, and then y plus 4 is what's left. That's a plus, so I'm going to put a plus. Common factor here is 3, and y plus 4 is left. As we can see here, y plus 4 is the common factor. So in this term, this is both terms have y plus 4 common. So I just factor that out, y plus 4. And what's left behind? Y squared plus 3, which is a sum of squares which cannot be factored anymore. And so our work there is done. Let's take a look at number 55. Same process again. I'm just going to pair up the first two, and then we're going to pair up the last two and see if those factor. So we have common factor for the first pair is 2x, and that leaves m plus n. Common factor here is plus 3y, and that leaves m plus n. Again, we have a common factor of m plus n, so we're going to factor that out. M plus n, and what's left behind is 2x and plus 3y, and that's it. That's factoring by grouping. Let's proceed here. I'm going to try to group this pair and see if that works. GCF of the first pair is 5a. So I divide 10ax by 5a. 5 times 2 is 10. A is already there, and x, we need that. And then negative 15 divided by 5 is 3. The a's would cancel, and then y would be there. Since this is a negative, I'm going to put a negative here because that's my best bet. Common factor between 8 and 12 is 4. Common factor between the variables is b. Negative divided by negative is positive, so 8 is 2. B's would cancel, and then x would be left behind. Positive 12 divided by negative 4 is negative 3. B's would cancel, y would be left behind. And we see that the parentheses are the same, so we factor those out. We get 2x minus 3y, and in the other parentheses we get times 4a minus 5a minus 4b, and that's that. Now let's try this one here. We're going to do common factor of that pair, common factor of that pair, and see what we get. First pair is x squared is a common factor, and x minus 1 is left. Next pair is negative 3 is a common factor, negative comes down, and x minus 3 divided by negative 3 is negative 1, also there. So we end up with common factor of x minus 1, and then x squared minus 3, which looks like a difference of squares. And if we push it a bit, we could say, oh well, what number do I square to get 3? Well, that number is square root 3. So that's an irrational factor, but we can leave it like do that possibly. And now let's move on to the next one. We try to find a common, we try to pair these off and pair those off. So the common factor here is 2s. And to make sure when you're writing your s's, it's not confused with a 5. Pretty easy to do. Common factor is r plus 2. Since that's a negative, I put a negative. Common factor is 1. So we're dividing each of these by -1. We get r plus 2. 2 is a common factor. So r plus 2 is a common factor. So we have r plus 2. And then the other pair of parentheses, we have 2s minus 1. Again, that's supposed to be an s, not a 5. That's that. And we're pushing through relatively easily through these. So this is a good clip. We're making a good pace. So let's move on here. Pair these guys up, but I made an error. I should always first, always check for the greatest common factor. And I recognized right then, but just as I was about to do the pairing, that I didn't check my common factor. But you know, 6 is a common factor for the numbers, and each term has a p. Now, some terms have q's and some don't, but every term has a p, so we're going to factor out 6p and see what's left behind. So when I factor out 6p here, there's going to leave a pq behind here. And then when I factor out 6p, I'm going to get a 3q. And then when I factor out a 6p, I get a -5p. And then that would leave me a -15. And now I'm going to try to factor the stuff in the parentheses by grouping. When I do that, I still have the 6p on the outside. But now on the inside, I have another pair of groupings. Common factor here now is q. And then the parentheses is p plus 3. -5, and then common factor is negative divided by negative is positive. Again, negative divided by negative is positive, and we see that the common factor here is p plus 3 inside the parentheses. I still have my 6p on the outside, but now the common factor is p plus 3, and the other terms are p minus 5, and I don't need those outer parentheses because of associative property of multiplication. And there we have it. Now, for this one, when I try to factor it, when I try to pair them up, look at what happens. I factor, I get x and then xy plus 6. And then I get -1. And I get 3x cubed plus 2y. That does not give us what I need. So that will not work. I cannot do it when they are arranged this way. So what I'm going to do is I'm going to rearrange a few things. And maybe if I just switch and put this y with that y, then maybe that will work. So we're going to switch the second term and the last term. So let's switch. Now let's see what we end up with, and I might need some space, so I'm going to make this switch a little bit tighter. So when I do that now, my expression becomes x squared y minus 2y minus 3x cubed plus 6x. Now let's see if that grouping will work. So sometimes you have to rearrange the expression to find a proper grouping. And there, let's check. Common factor here now is y, and we end up with x squared minus 2. And then common factor is -3x. And that leaves me with a positive x squared. Positive divided by negative is -2. And what do you know? The stuff in parentheses are the same. So I factor that out, x squared minus 2, and that's what's left is y minus 3x. And, we may be able to just do the further factoring here, but we won't. Now, in this case, just because of, well, if I try to do the factoring here by grouping, similarly to the first one, you'll see that we get stuck. We get 5x parentheses a plus 2b. But if I might put a minus here, minus 2c, I get a minus 2b. And that doesn't work. All right, because these guys are not the same. And it turns out that in this case, rearranging terms does not work in this case. So what we're going to just say, and you can try it, I'll leave you to check it out. Rearranging terms. Does not work. So in this case, we can say that this expression is prime. Can be broken down into simpler factors. All right, so what do we have? What we have is factoring by grouping and greatest common factor, and we have also done binomials. Now we're going to talk about factoring trinomials, and basically what we're doing is the backwards of foiling. So it's this PowerPoint calls it unfoiling. I don't call it unfoiling, but it's the opposite of foiling. Look at what happens when we're foiling. We multiply the first by the first, so that's how we get x squared. The outer by the outer, that's how we got the negative 8. And then the inner by the inner, and the last by the last. So when we're going backwards, x squared is because of x times an x, so an x in each pair of parentheses. The negative 8 is because of two numbers that when you multiply them, you got negative 8. But when that 2x came from the outer and the inner being put together, because both of them gave us x terms. So we need two numbers that when we multiply them, we get this negative 8. But when we add those two numbers, we get 2x. Those two numbers are negative 2 and 4. And those are the only numbers that work. Negative 2 and positive 4. So that's what we put in the other pair of parentheses. So that's basically a one-line factoring. So let's see how we do that. And just as a side note here, this slide explains the process of how we do it when the coefficient of x squared is 1, and then when the coefficient of x squared is a bigger number than 1. If it's negative 1, we'll just factor out the negative. So when the coefficient of x squared is 1, it's actually a relatively easy process. What we're going to do is we're going to put a pair of parentheses, two pairs of parentheses, sorry. And then we say the first term should multiply to be b squared. So one of them must be b and the other one must be b. Then I need two numbers that when I multiply those two numbers, I get a positive 32. But when I add those same two numbers, I get negative 12. Well, what are the numbers that multiply to be 32? 1 times 32, but those don't add up to be negative 12. As you can see, they multiply to be a positive, so the signs must be the same. But they add to be a negative, so both signs must be negative. Negative 1 times negative 32 is positive 32, but negative 1 plus negative 32 is not negative 12. If we try negative 2 and negative 16, still don't add up to be negative 12. Then negative 4 times negative 8, those do add up to be negative 12. So we can just put those in. And now if I try any other pair, that won't work. Although those are all the pairs we'll try. And again, with this one, similar thing. put a pair of parentheses, put an A in the beginning. Two numbers that multiply to be positive 27 but add to be negative 12. We can try negative 1, negative 27. That doesn't work. Negative 3, negative 9. Oh, that does work. So negative 3, negative 9. Make sure your 9 and your A look different. In this case, I still have my leading coefficient to be y 1, so I put y in both pairs. Now, two numbers that multiply to be a negative 24. Well, we know that one number must be negative and the other must be positive because negative times positive is negative. But if the signs were the same, they would have given us a positive answer. Now we need two numbers that when we multiply them, we get negative 24, but add to get positive 10. If you add them to get positive 10, then the bigger one has to be the positive because the bigger one will overpower, and that's the sign we keep. So let's see, negative 1 plus 24, that doesn't give you negative 10, positive 10. Negative 2 plus 24 gives you positive 22. That doesn't work. Negative 3 times positive 8 will be negative 24, but negative 3 plus positive 8 is 5. Oh, I just messed up. I went rushed past it and missed what I was doing. Negative 2 times 12 times positive 12 is 24. Negative 2 plus 12 is 10. So then we have a negative 2 and a positive 12. And there we have it. And you can check by multiplying, and you'll see that that's the answer. Let's try here. In this case, both numbers are positive, so we know that we're multiplying two positive numbers. So we have x plus a number and x plus another number. Two numbers that multiply to be 30 and add to be 10 to 13. And it's pretty easy to see that's 3 and 10. So at this point, I would recommend that you try these other questions on your own to see if you get the pattern, and then you can check your answers here. Again, we have z, leading coefficient is 1. So I put z first, and then they multiply to be a negative, so one answer is negative and the other is positive. But right here we see that they add to be a negative 3, so the bigger one is the more powerful one. Two numbers that multiply to be 28, it could be 1 and 28, 2 and 14, 3 and, well, not 3, 4 and 7. And you can see there that positive 4 plus negative 7 will give us negative 3. But positive 4 times negative 7 will give us negative 28. So those are our answers. And you really have to know your times tables here to work well with these. So if you're weak on those, be sure to practice them. For this one, this is a little bit weirder. We have p squared at the beginning and q squared at the end and a pq in the middle, which means we're multiplying p's and q's together. So since the front terms are p squared, we put p and p in the leading of each parentheses. And then at the end of the parentheses, since you're going to multiply to the q squared, the last term should be q's, because you're going to use q times q is q squared. Now I need two numbers that multiply to be negative 20, but when I add them, I get negative 1. So we can do 120. That doesn't work. 2 and 10. That doesn't work. 4 and 5. That does work, because negative 4 plus 5 is positive 1, but negative 5 plus 4 is negative 10. It's negative 1. Now again, these look easy when we do them, but you really have to practice to get the hang of them. So this next one here, we are going to first look for GCF, and it turns out there is a GCF 3. So I factor out 3. And what's left behind is x squared plus 4x minus 5. And so what I'm going to do is factor that trinomial. So I still have the 3 out front, but I still put my 2 pairs of parentheses. And then I put an x in the first pair and an x in the other pair. I now need 2 numbers that multiply to be negative 5 but add to be positive 4. We try 1 and 5. 1 times negative 5 is negative 5, but 1 plus negative 5 is negative 4. So we switch the signs. Negative 1 times 5 is negative 5. Negative 1 plus 5 is 4. So this, negative 1, positive 5. Now let's try these. Now these look a little bit different than what we're used to. So we notice here that with this one, number 18, the coefficient of x squared is not 1 and there's no common factor. So how do we do that? Here's how we do that. On this little chart here, I have quadratic case 2, which is when the coefficient is not 1. It looks a little tedious, but we have an example to illustrate here. So how do we go about this? Here's how we go about it. First, we multiply the leading coefficients, a times c. And then we find 2 numbers that multiply to be that product, but when you add them, you get the linear term, the middle term. So we find the product of the leading coefficient and the last coefficient, or the last constant if it's not a coefficient, and then find 2 numbers that give you that product, but when you add them, it gives you the middle term. Then we're going to turn that trinomial into a 4-term expression by just replacing the middle term by the sum of the 2 terms that we just found, the 2 numbers that we just found, with a corresponding variable. Then we have a 4-term expression that we can then factor by grouping. Here's an example. We have 6p squared plus 19p minus 77. So what we do is we multiply 6 by negative 77, and that will give us negative 462. Now, the next thing is we need to find 2 numbers that multiply to be negative 462, but add up to be positive 19. That's a little tricky. What we do know so far is that one number has to be a positive and one a negative, and the bigger one has to be the positive because they have to be a positive. But how do we come up with the numbers easily? This looks a little tedious to be trying numbers. So here's a little shortcut that we can do. We take the first original factor, 6, and we're going to write that as a pair of its common factors. So let's say we do 1 times 6. And then we can do that again as 6 is 2 times 3. So those are the factors of 6. Then we're going to do the same thing with 77. 77 can be written as 1 times 77 or 7 times 1, 7 times 10, 7 times 11. Now, I will take 1 pair of these and 1 pair of these and mismatch. So I'll take a 1. Let's say we'll go with the 1 times 6 and the 1 times 77. I could say 1 times 1 is 1 and 6 times 77 is 462. When you add those or actually subtract, you don't get 19. So that's not a right good pairing. But if I did 1 times 77 and 6 times 2, 6 times 1, I get 6 times 77. When I put them together, it still doesn't match. So apparently this doesn't work. What if I tried 1 times 7 and 6 times 11? That's 66 and 7 still don't work out for 19 when you subtract them. What if I did 1 times 11 and 6 times 7? That's 42 and 11. When I subtract, I still don't get 19. So this one is not what I want. So then I know I'm going to have to use 2 and 3. I'll go 2 times 1 and 3 times 77. That doesn't match. That doesn't give us something to give it 19. I can do 3 times 1 and 2 times 77, but that's still too big. But if I do 2 times 7 and 3 times 11, I can get 19. If I do 33 minus 14, I do get 19. So these are the pairs I need. So what I will then do is say, oh, well, 2 times 7 is 14, and 3 times 11 is 33. The bigger one has to be the positive, the smaller one has to be the negative. So the numbers I need are negative 14 and 33. So that's how I got those. Now that looks like a lot of tedious work, but if you can recognize the product and sum easily, you don't need to go through this. But if you can't, you might need to practice going through this process. Once I find out two numbers that multiply to be the product of 6 and negative 77 and add to be 19, now I'm going to replace the 19 with the sum of those two numbers with the appropriate variable attached. So I'm going to take out 19p and put 33p plus negative 14p, or 33p minus 14p, in either order. It's fine. Then I'm going to factor that resulting 4-term polynomial by grouping. Pair them up, get the common factor. The things in parentheses are the same. Factor that out, leaving the other things behind, and we're done there. So let's go through the process with number 18. So the first thing I'm going to do here is I'm going to multiply 2 by 15. And when I multiply 2 by 15, I recognize that that is 30. And I'm looking at the sign, positive 15 as well. So what I'll be looking for is I'll be looking for two numbers that when I multiply those two numbers, I get that product of 30. But when I add those two numbers, I get negative 13. Well, the two numbers that come to mind first are 2 and 15. But both have to be negative because they add to be a negative number. 2 times and multiply to be a positive 30. Negative 2 plus negative 15 is not negative 13, so that doesn't work. So the next pair I can try is 3 and 10. Negative 3 times negative 10 is negative 30, and negative 3 plus negative 10 is negative 13. So that looks like the right choice. Negative 3 and negative 10. Doesn't matter which order we do them. And then we just proceed back to replace only the middle term with the two terms that you just found, the sum of those two terms, and adding a negative is just subtracting. And then I can factor by grouping. So I'm going to group this pair and that pair and proceed. Common factor here is y, leaving 2y minus 3. I have a minus, so I'm going to put a minus. Common factor here is 5, leaving negative 10 divided by negative 5 is positive 2. Y. Positive 15 divided by negative 5 is negative 3. And you see the parentheses are the same. So then we can factor that out. We get 2y minus 3, and then times y minus 5. And there you have it. And you can check by distributing the parentheses. In this case, we have to rearrange it because we want the polynomial to be in standard form, which means from highest power of x to the of the variable to the lowest power of the variable. So we're going to rearrange this and rewrite as 6a squared plus a minus 5. And then we're going to proceed. We're going to see that if we multiply 6 times negative 5, that gives us negative 30. So I need two numbers that when I multiply them, they multiply to be negative 30. But when I add those same numbers, I get a positive 1, which is the coefficient of a. So the first numbers that come to mind are 5 and 6. Let's see. The bigger has to be the positive. So 6 times negative 5 is negative 30. And 6 plus negative 5 is positive 1. That does work. So 6, negative 5. 6, negative 5. Those are the numbers I need. So when I go back to my expression now, I keep the 6a squared. but I'm going to replace the a with 6a minus 5a. That's the same thing. But now I'm going to factor by grouping, because I went through this so I could get a 4-term expression and factor by grouping. I factor out 6a from the first pair, and that leaves me with a plus 1. I factor out -5 from the second pair, and that leaves me with a, and then -5 divided by -5 is still 1. Common factor here is a plus 1, so I factor it out. I get a plus 1 times 6a minus 5. And what do you know? We're done. Now let's move on to the last example on this page. Five u cubed v minus 30 u squared v squared plus 45 u v cubed. First rule of factoring is to check for common factors. And there's a 5 that's common to each of the numbers. There's a u that's common to each term. And there's a v that's common to each term. So when we do factor that, we get u squared minus 6uv plus 9v squared. Now, this is just coefficient is 1, so we can factor that very easily. So I can just write as a pair of parentheses, 2 pairs of parentheses. First pair has a u first, and then a v last, because we have v squared at the end and u squared at the beginning. And we need 2 numbers that multiply to be a positive 9, but add up to be a -6. Those numbers are -3 and -3. Now, what you notice here is that the things in parentheses, the parenthetical terms are exactly the same. So basically, we are multiplying something by itself. And when we multiply something by itself, we write that as a square. So we say 5u times u minus 3v quantity squared. Now that brings us to something interesting, and that is the concept of a difference of a perfect square trinomial. A perfect square trinomial. Let's talk about that quickly. So before I do that, just remember, always check for the greatest common factor first. Then look if it's a special case of a binomial, either a difference of squares, which factors to be a pair, the product of conjugate pairs, or the sum or difference of cubes, which you should memorize the rules there. Or if it's a 3-term trinomial, a trinomial factor, you kind of do the backwards foiling. And then if it's 4 terms, you want to do grouping. And there's other cases where you might have disguised quadratics or other terms that you might have to do some combined efforts. Now, let's take a quick look at this example quickly before we move on. 20y squared minus 45. First rule, is there a common factor? Yes, 5. When I factor out 5, I get 4y squared minus 9. Next, that's a binomial. What does it look like? It's a square minus looks like a square. That's a difference of squares. The conjugates then are 2y and 3. So the factor is 5 times 2y plus 3, 2y minus 3. There we go. Here's another one. First rule, common factor. 8 doesn't go into 20, but 4 does. 4 is a common factor. M is also common, and N is also common. So the common factor is 4mn. Then, when we factor out, we have 2m squared plus 5m minus 12n squared. So what we're going to do is try to do the unfoiling thing, which is factor the trinomial. We see that the coefficient of m squared is bigger than 1. So we're going to have to multiply the leading term, the 2, by the -12. That gives me -24. And now I need 2 numbers that multiply to be -24, but add to be 5. Those numbers are 8 and -3. I'm going to replace the 5mn with 8mn minus 3mn. So the expression in the parentheses becomes 2m squared plus 8mn minus 3mn minus 12n squared. Then I'm going to factor by grouping. I pair these guys up, I pair these guys up, factor out 2m, I have n plus 4n, factor out negative 3n, I have n plus 4n, and the n plus 4n is common, so I have 4mn, and then n plus 4n, and then 2m minus 3n. And you can always check that work by foiling or distributing terms. Now, let's talk a little bit about factoring, doing a perfect square trinomial. Perfect square trinomials factor, let's see. What happens is a perfect square trinomial occurs when you have a binomial that is multiplied by itself. And when you distribute it, you get a trinomial that's a perfect square. Now, this property of a perfect square trinomial is important. If I were to distribute our FOIL, x plus 6 times x plus 6, x times x will be x squared, and 6 times 6 will be 36. So the last term and the first term are both perfect squares. Now let's look at what we get for the middle term. We have x times 6 and 6 times x. So we're adding the same number twice. So the middle term will be 2 times something. 2 times what we get when we multiply the x and the 6. So the last two terms are perfect squares, and the middle term is twice the number that is at the end, the middle coefficient. Double the product of x and 6. So how does that work for us? Let's see what we're saying here. The rule then is to check if it's a perfect square binomial. First, the first term and the last term must be perfect square. And then the middle term must be double the product of the first and the last, the square root of the first and last term. So if you have an a squared and a b squared, then the middle term should be double a times b. And that could be either positive or negative. So let's try and see what that rule is. And by the way, I showed why this is on the right side here. A plus b squared is a plus b times a plus b. So that gives you a squared plus 2ab plus b squared. So you see, it's the first term times the last term times 2. That's the middle. Likewise, if it's a minus, a minus b squared, you get a minus here. Now, in this question, it says, fill in the blank to make the trinomial a perfect square. Now, I need to find two numbers. I notice here that 9x squared is the square of something. 9x squared is actually the square of 3x. And 25 is 5 squared. The middle term needs to be 2 times the product of this guy, 3x, and this guy, 5. And that's how we get our middle term, which in this case is going to be 30. 2 times 3 times 5 is 30x. And in reality, that could either have been a positive or a negative. But let's just go with the positive for now, since it seems that they're looking for the positive version. Let's go on to number 52. What do we square to get 16x to the 4? That would be 4x squared. And what do we square to get 1? Oh, that's easy. That's 1 squared. So now we need to multiply this 4x squared and this one by 2 to get the middle term. So we have 2 times 4x squared times 1. That gives us 8x squared. And in this case, since they put a negative here, we're going to just keep that there. Now let's take a look at number 53, and I'd like you to try these on your own and see what you get, and then check if it matches what we have. Now you notice here, this is b squared, and this here, this should be 2 times something times the b from b squared. this is b to the power 4. That is where we get that b here. So what number should go here? What do I multiply by 2 to get 12? Well, that number is going to be a 6. And then that 6 is going to be squared to get the number at the end. So the answer here is going to be 36. I recommend that you go back through that explanation again. Let's try this one here. This one is a little bit more tedious, but let's see what we have. 4w squared is actually the square of 2w. The middle term, 28w, came from the idea of multiplying 2 by 2w by some other number. So I'm going to adjust this a bit over here just for the sake of notes. I'm going to write that as I'm just going to put that right there as a b here times something else here. And that something else would be a 6, which is what goes there. You're squaring that, and that will give you the last term. Don't want my b to be confused with the 6. Now, in this case, 2w is what I multiply by 2, and then times another number to get 28. 2 times 2 is 4. 4w times what gives 28? 7. So we do 7 is the number we're looking for. And then what we're going to do with the 7 is we're going to square that 7. And that will become my answer right here, 49. Now we're doing it the backwards way here. We know that this guy is 1 squared. And we know that this middle guy here is 2 times something with a z times 1. Well, what thing times 2 gives 16? Oh, that's an 8. So that means this number here should be an 8. And then what am I going to do with that 8? I'm going to square that 8 to get the number that should go here. 8 squared is equal to 64. So we're going to put 64 right here. Again, we see that 49 is actually 7 squared. And 42, they have a negative here, but I'm just going to stick with a positive. So we have 2 times some quantity times x times 7. Well, 2 times 7 is 14, and we need it to become 42. So when do we multiply by 14 to become 42? 3. So that means the number I'm looking for here is the square of 3, which is 9. So the number I'm looking for here is 9. Now again, this looks easy when I do it, but of course, you have to really practice at these to get the hang of it. And now for how do we use this concept to solve equations, polynomial equations. There's a property in mathematics called the zero product property, where 0 multiplied by any number gives you 0. That property is unique to 0 because the other numbers don't force you to get a particular answer. When you multiply 1 by something else, you get that other thing. But 0 always forces you to get 0 when you multiply by 0. So that brings up the zero product rule, which says if two real numbers, multiply to be 0, then one of them is 0, or both of them are 0. So if two numbers multiply to be 0, at least one of them is 0. Now, how does that work with factoring? How it works with factoring is When you factor, you're writing that as a product of factors. That's what factoring means, expressed as a product of factors. So if I have a polynomial expression that's equal to 0, and I factor it, then I've just written a product that's equal to 0. That means one part or more of the product is equal to 0. And then we can use that idea to solve our polynomial equations. So let's take an example, a few examples here. Let's say we have x plus 3 times x plus 5 equal to 0. Well, that would mean that either x plus 3 is equal to 0 or x plus 5 is equal to 0 because the product is 0. That would mean that x would be negative 3 or x would be negative 5. So then that means the solution of this equation is either negative 5 or negative 3, writing them in numerical order. What we're saying is if x is negative 5, this equation works out to be true. If x is negative 3, that equation works out to be true. Those are the solutions, the values of the variable that makes the statement true. Similarly, if x plus 7 times x minus 4 is equal to 0, then that means either x plus 7 is equal to 0 or x minus 4 is equal to 0 because the product is 0. That means either one is 0 or the other. So we get x equal to negative 7 or x is equal to positive 4. So my solution are the numbers negative 7 and 4. When I plug either one in, you get a true statement. In this case, similar approach. 2w plus 9 times 5w minus 1 is equal to 0. That means either 2w plus 9 equal to 0 or 5w minus 1 equals to 0. That means 2w would equal to negative 9, and that means w would be equal to negative 9 over 2. Or 5w would be equal to 1, which means w would be equal to 1 over 5. And so you can check those to see they work, and I'm pretty sure that they do. And then we therefore have our solution, negative 9 over 2, comma 1/5. Those are my solutions. Again, number 20 is similar. 3a plus 1 equal to 0 or 4a minus 5 is equal to 0. Now, these that we just did were already factored. So we didn't have to get them to be written as a product of because they were already factored. That won't always be the case. So the answers for this are negative 1/3 or 5 over 4. In this case, we have three parts, three factors, but they all multiply to be 0. Same rule applies. Either x is equal to 0 or x plus 4 equals to 0 or 10x minus 3 equals to 0. Well, that would mean x is equal to 0 or x is equal to negative 4 or x is equal to 3/10. So my solutions now has three values, negative 4, 0, 3/10. I'm writing the answers in numerical order from left to right. Similarly, number 22, t is equal to 0 or t minus 6 is equal to 0 or 3t minus 11 is equal to 0. That would mean either t is equal to 0 or t is equal to 6 or t is equal to 11 over 3. So my possible answers are 0, 11 over 3, and 6. Those are in numerical order. Now, let's take a look at number 25 because number 25 does not look like the ones that we just did. And as you can see, it's not factored. But that's not a problem. That's a trinomial with a coefficient of x squared. Of 1, sorry. For x squared, it's a leading coefficient of 1. So I just do a pair of parentheses, two pairs of parentheses. X is in the beginning. Two numbers that multiply to be negative 27 but add to be positive 6. That sounds like positive 9, and negative 3. Which means x plus 9 times x minus 3 equals to 0. That's a zero product. So we set each factor equal to 0. X plus 9 equal to 0, or x minus 3 equal to 0. It's important to know that everything must be equal to 0 before you factor. Otherwise, this approach does not work. So then that leaves us with x equal to negative 9, or x is equal to 3. And then you can always check. I'll leave you to check these. The solution is negative 9 or 3. Negative 9 squared is 81. Negative 9 times 6 is 54. 81 is negative 54. 81 plus negative 54 is 27. 27 minus 27 is 0. 3 squared is 9. 6 times 3 is 18. 9 plus 18 is 27. 27 minus 27 is 0. So that does work. In this case, we also have a polynomial equation, but it's not equal to 0. So we're going to write it in standard form by moving the 3 to the left side. And so we end up with 2x squared plus 5x minus 3 equals 0. And as you can see, this is no common factor. It's a trinomial, but the coefficient of x squared is 1. So what I'm going to do is multiply the 2 by the negative 3. That gives me negative 6. I need two numbers that multiply to be negative 6, but when I add them, I get 5. All right, so negative 6 times 1, but the bigger one has to be the positive. So 6 times negative 1 is negative 6, and 6 plus 1 is 5. So there we have it. So we have 6, negative 1, 6, negative 1. So what I'm going to do is replace 5x with 6x plus negative 1x, or I can just write it as minus 1x. Everything else stays the same. I'm going to proceed with the factoring. I'm going to factor by grouping. Pair up those two, pair up those two. So we end up with common factor for this pair is 2x, leaving x plus 3 in the parentheses, minus, there's no other common factor but 1, so I'm going to put the 1 and then do negative 1 divided by, negative x divided by 1 is negative x, negative 3 divided by 1, negative 1 is positive 3, still put my equal 0. X plus 3 is common, so I factor that out, x plus 3 times 2x minus 1, and then I set each factor equal to 0. X plus 3 equal to 0, or 2x minus 1 equals 0. That means x is equal to negative 3, or x is equal to positive half. And I will leave you to check the answer there. Let's move on. Here we have a few more to do. For this question, we just move the 11x to the left side, to the right side. So we have 3x squared plus 11x minus 4. And since equals is symmetric, it doesn't matter which side the 0 is on. We go through our process again. We multiply the 3 by the negative 4. And I need two numbers that multiply to be negative 12, which is 3 times negative 4. But when we add them, we get positive 11. So those two numbers are 12 and negative 1. So when I rewrite this equation, I get 0 equal to 3x squared plus 12x minus x minus 4. And similarly to what we did in the previous question, we should approach the same. Factor by grouping. Factor out 3x, I get x plus 4. Factor out negative 1, I get x plus 4 again. Common factor is x plus 4. So we have x plus 4 times 3x minus 1. We set each part equal to 0, x plus 4 equal to 0, or 3x minus 1 equal to 0. And that will give us x equal to negative 4 or x equal to 1/3. So my solution then is negative 4 or 1/3. Let's jump to number 30. Now, the temptation is to divide both sides by the variable, but do not do that, because what if the variable is equal to 0? You'll be doing two things. You'll be doing something illegal. You would be dividing by 0. And secondly, you would lose a solution that would possibly be there, because 0 is a possible solution. So never divide by a variable, because if you're solving an equation. So what we can do though is subtract the variable term from both sides and then go about factoring. Common factor is x. Now we have two factors, so that means x equal to 0 or 5x minus 7 equal to 0. And then that means x equal to 0 or x is equal to 7 over 5. And that's that. And again, you can just check that on your own. 0, 7 over 5. If we had divided by x, we would have lost that possible 0 solution. And again, with number 37, I'll leave you to try though. That one is very simple, straightforward. Number 38, we have 2x. That product, 3 products equal to 0. So we'll just say x squared, 2x equal to 0, or x minus 4 squared equal to 0, or 4x plus 3 equals 0. Well, to get 2x equal to 0, just divide both sides by 2, you get x equal to 0. For this one, you take the square root of both sides. So really what we're doing is x minus 4 square equals 0. I'm doing the square root of 0. And that will leave us with just the parenthesis, stuff in parentheses equal to 0. So what we have now is x equal to 0 from the first factor, and x minus 4 equal to 0 from the second factor, and x equal to negative 3/4 from the third factor. So the answers are x equal to 0, x equal to 4, or x equal to negative 3/4. So my solution then is that either negative 3/4, 0, or 4. Now these last two questions on this page are a little tricky because it's not equal to 0. So what we have to do is actually distribute the parentheses and write the equation in standard form. Negative 62 is equal to t squared minus 16t plus 2. Now we get the negative 62 to the right side. We get 0 is equal to t squared minus 16t plus 64. Now let's stop and take a quick look at this. That's a square, and that's a square. 8 squared is 64, t squared is t. 8 times t times 2 is 16. That's a perfect square trinomial. Let's see if that's really what happens. I need two pairs of parentheses, t and t. Two numbers that multiply to be positive 64 and add to be negative 16 are negative 8 and negative 8. So that means 0 is equal to t minus 8 squared. I can then solve for t by taking the square root of both sides. The square root will undo the square. and then I would have t minus 8 equal to 0. That means t is equal to 8. And that's my only solution, which you can always check to verify. For number 39, we can't just set this equal to 0 because there's an 8 there. In reality, what we'll have to do is distribute the parentheses, in this case FOIL, and then get the whole expression equal to 0. So y squared plus 4y minus 3y minus 12 equal to 8. Then we get the 8 over to the left side by subtracting it to both sides, subtracting it from both sides. And we end up with y squared plus 1y minus 20 equal to 0. This we can factor pretty easily. Y and y, two numbers that multiply to be negative 20 and add to be positive 1 are positive 5 and negative 4. And so we know that y plus 5 equal to 0 or y minus 4 equal to 0. So that means y is equal to negative 5 or y is equal to 4. So my solution then is negative 5 and 4. Let's try a few more here, and then we will go to the last thing, which is word problems. So for this one, we're going to distribute the parentheses. Two a times a is 2a squared. 2a times negative 1, negative 2a. Negative 1 times a, negative a. Negative 1 times 1 is positive 1, equal to 6. I'll move the 6 to the left side so everything is equal to 0. And I end up with 2a squared minus 3a minus 5. So I need two numbers that multiply to be negative 5 and add up to be negative 3. Those two numbers, sorry, negative 10, multiply to be negative 10, because it's 2 times a negative 5. Two numbers that multiply to be negative 10 and add up to be negative 3. Those numbers are negative 5 and positive 2. So we have 2a squared minus 5a plus 2a minus 5 equal to 0. I factor out an a. By grouping, I get 2a minus 5. Factor out a 1, I get 2a minus 5 again. I factor completely, I get 2a minus 5 times a minus 1. A plus 1, sorry, equal to 0. And then for the sake of space, we'll see that a would therefore be equal to 5 halves, or a is equal to negative 1. And so the solution then would be negative 1 comma 5 over 2. I leave you to check the answer for that. For number 42, similar process, although a simpler distribution. We get 6w squared plus w equal to 2. That means we have 6w squared plus w minus 2 equal to 0. And so when we do the breakup here, two numbers that multiply to be negative 12 but add to be positive w could be negative 3w plus 4w. Factoring by grouping, common factor here is 3w. And then we have 2w minus 1. And then plus 2. And then 2w minus 1. And then our factors are 2w minus 1 and 3w plus 2. So that would mean 2w minus 1 equal to 0, or 3w plus 2 equal to 0, which we can solve very easily to see that w is equal to 1/2, or w is equal to negative 2/3. Number 44. See, we have another situation here, so I'm going to have to rewrite that x plus 2 squared as x plus 2 times itself. And that gives me x squared plus 2x plus 2x, which is 4x, plus 4 equal to 100. So that gives me 2x squared plus 4x, and then if I subtract 100 from both sides, minus 96. And I realize I can divide both sides by 2, so I'm going to divide both sides of the equation by 2. I'm not dividing by a variable here, I'm dividing by an actual number. So we end up with x squared plus 2x minus, and 96 divided by 2 is 48. And I can factor that by just using my shortcut method for trinomials. X, two numbers that multiply to be negative 48 and add to be positive 2 would be positive 8 and negative 6. And then we set each factor equal to 0. And then we solve x equal to negative 8 or x is equal to 6. So the solution here is negative 8 and 6. Now let's try number 45. For number 45, we'll distribute the parentheses and combine like terms. 3t squared plus 5t plus 15t, sorry, minus t squared. And then we'll just move these guys over, minus 2t squared minus 4t plus 1. So what I did was I moved each of these terms to the other side. Now when I look at these, I have 3t squared minus 2t squared minus 2t squared. All of those t squared got cancelled. And what we have left are 15t minus 4t is 11t plus 1, which is just a linear equation that can be solved very easily. 11t equal to negative 1, so that means t is equal to negative 11. Negative 1 over 11. And there you have it. For this one, number 48, we have to try this by factoring. The common factor is 2p, and then we have p squared plus 10p plus 21 in the parentheses. We can factor that. We get p plus 3, p plus 7. So our factors are 2p, which is equal to 0, or p plus 3 equal to 0, or p plus 7 equal to 0. So p is going to be equal to 0, or p is going to be equal to negative 3, or p is going to equal to -7. Those are our possible solutions. And last on this page, 12x cubed equal to 27x. 12x cubed minus 27x is equal to 0. Never divide by a variable. We factor out the 3x here, we end up with 4x squared minus 9. That's a difference of squares. So we can factor that again. 3x times 2x minus 3 times 2x plus 3, the product of the conjugate pairs. Setting those equal to 0, we get 3x equal to 0. (3x equal to 0), or 2x minus 3 equals to 0, or 2x plus 3 equals to 0. So that means x is equal to 0, or x is equal to 3 over 2, or x is equal to -3 over 2. And those are our answers. Finally, we're going to do a few word problems to get us into the mindset of how to do these. Applications. Now, I will not do all of these word problems, but I will display them for you so that you can try them on your own and then you can check them. So let's start off with a few and then I'll just display a few more and then leave you to work those out. The square of a number is equal to 20 more than the number. If you recall, when we're doing word problems, you read it all the way through, identify key concepts, key words. Square of a number is equal to 20 more than the number. So if that number is x, then we're saying the square of the number is x squared, and that's equal to 20 more than x. That's relatively easy. That means x squared minus x minus 20 is equal to 0. We can factor that. X minus some number and x plus some number equal to 0. That would be x minus 5 and x plus times x plus 4. So that means either x minus 5 equal to 0 or x plus 4 equals to 0. So that means x is either equal to 5 or -4. So the solution then is -4 or 5. Now let's check if we're correct. The square of a number, the square of -4 is 16, is 20 more than the number. 16 minus -4 is 20. That works. The square of 5 is 25. 25 minus 5 is 20. So that does work. The product of two consecutive odd integers is 63. Find them. So if one integer is x, then the other integer must be x plus 2. They're consecutive odd integers, so they jump by 2's. So when we do the product, we're doing x times x plus 2, and that gives us 63. So then we'll distribute and see what we get. So we get x squared plus 2x equal to 63, which means x plus 2x minus 63 equal to 0. We can factor this, sorry, x squared. We can factor this and we get x plus 9, x minus 7 equal to 0. That means either x is equal to -9 or x is equal to +7. Now, they said the first number is x. The first number is x. The next number, you add 2. So then that means if this is the first number, then the next number is negative 9 plus 2, which is negative 7. And if this is the case, the next number would be 7 plus 2, which is equal to 9. So the solutions are negative 9 and negative 7, or 7 and 9. And when you do multiply those numbers, you do get positive 63. Number 59. A rectangular pen contains 35 square feet of area. If the width is 2 feet less than the length, find the dimensions. So when we have a question like this, we want to draw a diagram. So I want to draw a rectangle here. Okay. Did a little error here. Let me try it another way. There we go. So what we do know, let's say the width is W. That means the length, well, let's say the length is X. Let's say the length is X. That means the width is 2 feet less than that. So take off 2. And the area is equal to 35 square feet. Well, we know that area of a rectangle is equal to length by width. Length multiplied by width. So we're going to do 35 is equal to X times X minus 2. So 35 is equal to X squared minus 2X. So X squared minus 2X minus 35 is equal to 0. Then we solve. We do X minus 7 times X plus 5. So that means X is either going to be 7 or X is going to be negative 5. Now, since the width cannot be negative, we cannot have a negative width. The only possible answer we have, lengths cannot be negative. X was the length. Lengths cannot be negative. For that matter, widths cannot be negative either. So the only answer we have that's reasonable is 7. Which would also mean then that the width is 2 less than that. 5 feet. Now here's a little challenging one, and we're going to stop with this one. The height of a triangle is 1 inch more than the base if the height is increased by 2 inches while the base remains the same. The new area is 20 square inches. Find the base of the and height of the original triangle and find the area of the original triangle. So let's draw the original triangle here. So let's say we have the original triangle. So this is the base of the triangle, which I'll write as a B. And the height is equal to 1 more than the base. The height is the perpendicular distance from the base up to the tip. Now, that's the original triangle. Okay, now the new triangle. What they did was they increased the height by 2, but they kept the base the same. So in this case now, the height is b plus 1 plus another 2. And the base is still b. So now this area is equal to 20 square inches. So if you recall from a triangle area, area is equal to 1/2 base times height. So the area of the new triangle, so new area is 20, and that's 1/2 times the base times the height, b plus 3. If we multiply both sides by 2, we end up with 40 is equal to b times b plus 3. And this one you have to distribute the b and solve the equation. So we end up with 40 is equal to b squared plus 3b, which would mean that b squared plus 3b minus 40 is equal to 0, which means b plus 8 b minus 5 equal to 0, which means b is equal to -8 or b is equal to 5. Of course, the base can't be negative, so that leaves out that answer. So then, for part A, the original base is 5 inches, and height would be one more than that, 6 inches. And then for part B, the original area is 1/2 base times height, 15 square inches. Now, this was quite involved, quite a bit that we covered. Hopefully when you watch this video, you learned, you didn't do it all in one sitting. It's quite a bit to cover. And here are 3 more exercise word problems that I haven't done, but I'm leaving them for you to complete. Additionally, I encourage you to use Khan Academy and practice doing questions on that website. And as well, I recommend you can also get practice on openstacks.org. Khan Academy also has good videos to explain the concept. Please remember to practice and continue working. And just a reminder, OpenStax is OPENSTAX, and you can also get the app on Android and the Apple. And Khan Academy is KHAN Academy, ACADEMY.org. All the best and keep learning.